So let's take a look at how our vector-valued functions and position, velocity, and acceleration can be used to understand projectile motion. So let's imagine we have a projectile, an object that is going to be thrown or launched from an initial height of h naught, so because that's in the vertical direction, we'll call that h naught j, with an initial velocity of v naught, which we are looking at as v naught cosine theta in the horizontal direction, and v naught sine theta in the vertical direction. So in some sense, if you remember from physics, if you've had physics experience, this is like a resultant vector whenever we've added the horizontal and vertical components together. And we are letting v naught be the magnitude of the initial velocity. So this is really the initial speed. So the initial speed and its direction in the x direction, and then the initial speed times really its vertical direction. So we're decomposing that initial velocity into its horizontal and vertical components. Now what we know from this is our initial position, r of 0, is going to be h naught j hat. And then, of course, our initial velocity, being v naught, will tell us that r prime of 0, which is our initial velocity, is equal to v naught hat. So from Newton's second law, we know mass times acceleration is going to be negative mg j hat. So negative mg is going to be that weight of that object, because g is our gravitational constant. So we will use g equals 9.8 meters per second squared if we are in meters per second, meters and seconds if we're in the metric system, or we can use 32 feet per second squared. So if we go ahead and divide both sides by m, we get the acceleration is equal to negative g in the vertical direction. And we've already said that v naught is the initial velocity. And so if we integrate negative g, we get negative gt j hat. Now imagine for a moment if we let t equal 0. If t equals 0, this component will disappear and we're left with just c1. So this term would disappear and we're left with just c1. So r prime of 0 would be just v naught. And so we have negative g t j hat plus v naught. And we've said that the initial position is h naught j hat. So if we integrate yet again, we get the integral of negative gt will be negative 1/2 gt v naught is constant, so that'll be v naught t plus our constant, we'll call it c2. And again, if we let t equal 0, this term will disappear, this term will disappear, and we're left with c2. So c2 is just h naught j. Now to make it easier on ourselves in a moment, let's go ahead and write v naught hat as v naught cosine theta t, and that's I hat, plus v naught sine theta t j hat plus, and we said C2 is H naught J hat. So if we look at our I components and J components, our I component is just V naught cosine of theta T, so Ti hat, plus we have -1/2 GT plus V naught sine of theta T plus H naught, and that's all the J hat component. So if we think about this parametrically, this is our X and this is our Y, which is why we end up with the parametric equations for our projectile as given here. So V naught cosine of theta is just the initial velocity in the x direction. V naught sine theta is the initial velocity in the y direction. So let's take a look at an example. So a baseball is hit 3 feet above the ground. So that's our initial height. So H naught is 3. An initial velocity of 152 feet per second at an angle of 30 degrees. So the 152 feet per second, that is our speed of our projectile. And the angle is 30 degrees from the horizontal. So let's go ahead and write our equations. So V naught cosine theta T is going to become V naught is 152 cosine of 30 degrees, and that's times T. So X equals 152 root 3 over 2T, which means that X equals 76 square roots of 3 times T. Make sure that T is not underneath the square root. So now Y equals -1/2. We will use 32 for G, T squared plus V naught sine of 30 degrees times T plus our H naught is 3. So this gives us -16 T squared plus 76 T plus 3. So just to summarize succinctly, X equals 76 root 3 T. Y equals -16 T squared plus 76 T plus 3. And the first question asked is, at what time will the ball hit the ground? So to determine that, that's whenever the height of the projectile is going to be 0. So let's set Y equal to 0. And that'll give the time of impact. So we have -16 T squared plus 76T plus 3 equals 0. Whenever we're solving a quadratic equation, it's usually nice to have the leading coefficient be positive. So let's take and change the signs on both sides. And this will require the use of quadratic formula. So we have T equals 19 plus or minus the square root of 373 over 8. Now keep in mind that T can't be negative because t does mean time here. So this gives us t equals 19/8 plus the square root of 373 over 8. And we'll go ahead and approximate that. T is approximately 4.79 seconds. Now the next question is, what is the speed upon impact? If we want to find the speed upon impact, let's first find the velocity upon impact. So to find the velocity, we need to find x prime of t, which will just be 76 square roots of 3, and y prime of t, which will be negative 32t plus 76. So at impact, we are looking at this time value. So let's find x prime of 4.79, and that will be 76 square roots of 3. Y prime of t will be 4.79 for t. Sometimes you might see this referred to as capital T, or you might see T sub max, something along those lines. And so plugging in 4.79, we get about negative 77.28. Now I just want to pause for a moment. Notice that this value is negative, and that's because this is our velocity in the vertical direction. So this object should be falling at that point. And so our speed upon impact is about equal to the sum of the squares of these components. Take the square root. And so this is about 152.64 feet per second. Now the last component is, what's the range? So that is the horizontal distance traveled during the time of flight. And so the range would be simply the x value evaluated at this time that we found initially, the 4.79 seconds. So x of 4.79 is about 76 square root of 3 times 4.79, and that yields for about 630.54 feet. Now, it would be worth noting at this point that this baseball and all the projectile motion that we've dealt with at this point has not accounted for air resistance, which would, I think, really, instead of being a parabolic motion, looking like this, we would actually see something more perturbed and making it more squat. So it would perturb the parabola. But that's much more difficult math and requires differential equations to solve. So here we have a projectile being fired at ground level. So that automatically means that h naught is 0. Our angle is 12 degrees. We do not know the initial speed. This is unknown. And in fact, this is the goal. And we know that the range is supposed to be 150 feet. Okay, so what do we know? X of t is going to be v naught cosine of 12 degrees times t, and y of t is going to be negative 1/2 gt squared. So we're in feet, so g will be again 32. So we have negative 16 t squared plus our v naught sine of 12 degrees times t, and h naught is 0. And so those are our parametric equations, and we know that T max is 150. So to figure out how to use this information, well, think back at the last problem. T max is whenever the height of our projectile is 0. So let's set y of t equal to 0. That's negative 16 t squared plus v naught sine of 12 degrees t equals 0. If we factor out t, we get negative 16 t plus v naught sine of 12 degrees. Now, this yields t equals 0, and t is going to be v naught sine of 12 degrees over 16. We can disregard the t equals 0 because that is the time of launch. So this is T max. Now we can use the fact that x evaluated at that time is 150. So x evaluated at v sine of 12 degrees over 16 should equal 150. But that means that we're plugging that value in for t. So we will have v naught cosine of 12 degrees times v naught sine of 12 degrees over 16 equals 150. So this is v naught squared sine 12 degrees cosine 12 degrees equals 2,400. Now, we could be really clever and use a double angle identity for sine, but we don't need to. V naught squared will be 2,400 over sine of 12 degrees cosine of 12 degrees. Disregarding any negative quantity for our velocity, because this is actually our initial speed, this is not a vector, then we can just take the positive square root of this quantity, and we get about 34.4 feet per second.